Next up, we have Anuj Tyagi, Senior Site Reliability Engineer, Ring Central Inclusive USA. Anush Tyagi is a seasoned professional with over a decade of experience in designing, building, and securing cloud infrastructure for large scale products. His work focuses on leveraging improving software engineering using artificial intelligence to enhance customer experiences while adhering to best practices in security and innovation. Anuj is deeply engaged in research, advocacy, and the ethical application of generative AI technologies. He has authored and co authored several research papers on topics such as cloud computing, security risks, and countermeasures, and ethical AI practices. As an active speaker and mentor, Anuj regularly shares his knowledge with the broader technological community. He is the co founder and technical advisor of AI TechNav, a platform dedicated to providing career guidance to students and professionals in computer related fields. Through this initiative, Anuj mentors aspiring individuals in software engineering, cybersecurity, and artificial intelligence, empowering them to build successful careers in technology. Anuj has also made significant contributions to open source projects, showcasing his commitment to advancing the community and fostering innovation in tech ecosystem.
Okay, thank you very much for the uh, introduction. I'll start my presentation. Can you see the presentation on the screen?
Yes, sir, it's visible.
Is it showing the slide? Just one second. Just making sure the correct screen is visible. I think this is the correct one. Okay. Uh, yeah, thank you for the introduction. So I am presenting giving talk on the topic service mesh, which is particularly use case that I implemented during my experience in a microservice architecture. So to begin within the time now, applications are evolving. Earlier, they used to be mostly monolithic, and then these new architectures are coming, which are one of them is used a lot now, is known as microservices. In monolithic, we have uh, applications bundled in a way like front end, back end, and uh, but in microservices, they are split up into uh, components based on the functionality. So this shift brings benefits like agility, scalability, and zero uh, zero loss deployment. And that, but then introduces new challenges also, especially in managing communication between those microservices, and to make that communication secure and reliable. Uh, for that, one of the approach is service mesh that we're going to talk about. So let's talk about the uh, challenges we face in microservices a little bit more. Uh, it shines in modality. That means we are able to split up the logics, and it works well with that. But as you scale, the operational challenges comes, and service communication become complex. Uh, like to know which services have to talk to which one and how to route the traffic between them. So this way, so this is mostly I'm talking about in terms of Kubernetes, which is also used a lot, but it should be valid with other similar uh, topics like tools or tech like OpenShift. Uh, so as the service communication become complex and debugging also become a lot harder, and security also can also become a concern. So, so how do we manage them efficiently? As we discussed, one of the option is service mesh. Service mesh is designed to handle these operational challenges, and think of it like a dedicated infrastructure layer that manage how services will communicate with each other. It provides features like security, traffic control, and observability. So it covers a lot area which we were facing challenges without requiring changing in the application code logic. So developer don't need to configure these logics. It can be done on the infrastructure side. That save time of the developers to focus on the feature side than on the reliability of the application, the infrastructure layer. Talking about the core features on Service Mesh, they basically divided into two planes, control plane and data plane. So like control plane where we are configuring and applying those policies, and data plane is mostly proxy that get added to those microservices. And in with the example where I implemented is with Istio, I used NY proxy, and the key feature for this is like it can help allow us to do the protocol conversion, and it supports mutual transport layer security, which is like MTLS. So both microservices can communicate through MTLS. So it's similar to like TLS protocol in the web browsing, but it's within the microservice communication, and also allow us to perform the intelligent traffic routing by using circuit breakers and retry. I will understand them more, and also support the observability of the microservices. So this help us to provide the insight feature when these microservices are communicating, what is exactly happening within them, because that was one of the biggest challenge we were missing earlier. And it allows to perform the service discovery, which should also help in the observability and also in the services communication. uh, and then when if we have to do the service testing also uh, between the microservices in terms of like machine learning model based deployment, or in terms of even the development microservices by traffic splitting and A/B testing. Those also are microservice mesh is also useful in those cases. And also like if you want to uh, shift the traffic or divide the traffic into like high availability of the microservices, or like between any of the different microservices, that can also be done with that. So in the microservice domain, it is very useful for the intercommunication of those services. Uh, what are the problems faced when we are doing those implementing the service mesh? And so when we are not using service mesh, what can be the problem? It should be the question. So because when the services are communicating with each other with maybe something without service mesh, could be using the APIs of those services, and there can be a problem with the timeouts and security concerns, and then retry between those communication and the monitoring of those internal communication, what's happening between them. So one of the example of like how it solves one of the challenge is, let's take this example of four services are here. We have red, blue service and C service, which is stateful, basically communicating through TCP. And then there is service D. So now in this kind of system, what happened if there's a red service called the blue service, uh, but then there's a problem where the blue service has a connection failure or on a timeout. And now, what should red service do? Because in this kind of a scenario, that must be handled by the if this is handled by the service code, It'll distract the developer from actually focusing on the business logic, and which is more important. I mean, in for from the developer perspective. And the next blue service then called the yellow service, but then there is a twist here. Uh, the yellow service exposing the TCP connection and not the API. So this forces the blue service developer to learn more about the TCP communication on one side, and maybe he is not more much familiar with that, so he'll need to spend time on understanding that, and that can delay the service release. And then finally, blue service calls the green one and get the error. What should we do to retry logic to be implemented in the service code, which can again distract the developer from focusing on the business logic. So this is where service mesh can be added layer, and that can help developers from all the components within the world product to avoid spending time on these things. So service mesh in a way is a collection of components that sit near the service, and it controls the logic for all these communication purposes instead of the service, right? And another concept of circuit breaker can also be explained to solve, which is solved by the service mesh. So the goal circuit breaker is to prevent cascading failures when the service fail. Basically, one of the service fail when they're communicating. So what it means that if we have three services, red one calls the blue one, which in turn calls the green one. And now if the green service fails and timeout, then blue service also respond to call from red one, and then wait for the green one to give the response. And then what happened in that case? Blue ones also time out after waiting for a period of time. The result of this will red one will get timeout based on the error in received from the green one. So yeah, it may sound a little confusing, but it's just more like a communication between those services. So now the problem can even get worse if the blue service get more and more API request call, and it can get throttled. And the other result can also make more and more calls to the green one, which in result give more timeouts. So in a way, it can, if one of the service is receiving requests from client, it can also and client multiple clients are trying to communicate, and those service like this red service and keep forwarding those requests to the blue one. It can, and the problem is in the green one. So in that way, blue one can get throttle, or in a way can get DDoSed. And if blue one is even able to handle it and just giving the 5xx response back to red one again and again, it can uh, overflow the resources of the red one also. So prevent this scenario, we implemented, I mean, the service mesh has implemented the circuit breaker in front of the green service. Circuit breaker monitor the service and check how many timeout it experience. If the number goes above threshold, the circuit breaker come into action and cut the service off. And then it can be done by the service itself also. But in this way, uh, service basically it runs on in a Kubernetes pod or a separate like in a container. So that way, those services are not getting impacted. It's the service mesh which runs as a sidecar that will handle everything. So from now, when a call to green is sent, the circuit breaker will respond to an error and then will not wait for the service to timeout. So this way we prevent cascading fellow of the service, and blue one will not experience timeout as a result of the green service problem. So this is a circuit breaker in a nutshell, which is taken care by service mesh. So among these various service mesh tool available, is the one which I use more, and it provides the deep integration with the Kubernetes also, which makes an excellent choice for container workload management and and to handle the challenges we face in microservice. So Istio consists of control plane and data plane, as we discussed already, and has a envoy proxy on the as a sidecar. So when we say as a sidecar, it's just Kubernetes has the smallest component of the service is a pod. So in that pod, service runs as a container. So it also becomes the this at sidecar also become as another container within that pod. So and it runs as a proxy in that. So Istio handle resilience by automating the retry, timeout, and circuit breaker. It support the controlling of canary deployment also, and which is useful in gradual rollout. So in this way, like I mentioned here with the diagram, is if you have like a multiple pods for one feature, for example, like to manage the traffic, or if some of those pods go down, then the traffic should be handled by other those pods also. So so in that case, when if the new release is coming in the current deployment, if the new release, will call it version 2, and currently we have version 1, and in that case version 2 is being deployed on for example, for one feature maybe we have 10 pods, so it will go on pod 1, and we're going to have metric to and we'll send either fake traffic, or send or after that we'll send a part of traffic, maybe not from the real customer, but from our internal traffic. So to test initially, and if the service is still getting healthy response, then we can incrementally increase the new release to other pods also. So this way, current development helps to safely deploy the services and roll out in the production. So with Istio, we can fine-grain control over traffic management this way, and we can dynamically route the traffic in the A/B testing also. It can reroute the traffic automatically when service experiences an issue. So this ensure uninterrupted user experience. Istio also excel in securing microservices. We talked about mutual TLS. It it can encrypt the traffic between the communication when communication is happening between those services, and we can enforce policy between those microservices and automate by adding those certificates also, like a digital certificate, which can reduce the burden on developers to handle all those logics like. So what is the workflow for providing the security policies? How can be applied? This is like a flowchart. So as we see, the authorization policy, support basically allow deny and custom actions. So we can apply multiple policies also. It doesn't mean that we need to have only one policy, and they will be more like a top to down bottom approach. So rule those are applied first will be checked first and read in a order, and so yeah, it's still going to check those in the order, and f- is to first check if there's a policy with action applied, and then it's check if there's a request match the policy specification, and if the request doesn't match the policy in one of those layer, then check the goes continues to the next layer of the policy. The other part is also like a observability area, and in terms of observability, tracing is also a very well known part in addition to logging the application. For tracing, the open tracing and Jaeger are most popular, uh, used as the tools for implementing tracing. But to give those observability what's happening between to get that data, or to collect those, we can integrated with the Prometheus, and here also service mesh can be useful to monitor the health of the services. So here are some of the results which in my implementation, which provide useful and helpful. Uh, so in kind of a peak traffic, in case terms of traffic improvement, it was useful to handle more traffic because there were no resource wastage on the from the service perspective on the retry or the timeouts, and we can apply the traffic shifting here though, so it saves our infrastructure bandwidth in that way. And in those kind of failures also reduced to almost minimal, to like 94% reduction in failures between the services. And in the infrastructure cost also, because of that, less bandwidth and less resources uh, were can be used for the similar traffic pattern. So that also helped us with the 30% savings. And in terms of security improvement, by adding the mutual TLS, when earlier the servers were communicating with each other without any encryption, this helped with providing the complete coverage earlier, and which was almost minimal, uh, because for the development teams it was less of a priority. The feature rollout was more on the focus, and that's how it is. In the security audit coverage, I found, I mean, the audit were giving the results in the security incidents were coming, and there were more policy violations were coming up with, for example, with the tools like earlier in the earlier presentation, we were being explained how DevSecOps pipeline work, and how that policy violations and security incidents are monitored or like displayed. So this, with using the service mesh and applying those security policy, those were almost minimized and reduced. In terms of observability, like we have more visibility now through our monitoring and getting metrics from the data, getting more insights from the microservices. uh, the visibility become 100% from 30%, and the debug time also reduced a lot in case of any incident or any issue we are facing, and this helped to provide like better customer experience and improve the performance issues. So we can say, as we are adding overhead with the service mesh, by adding the sidecar, so it is adding a small amount of resource, and then it's also adding configuration complexity from the infrastructure point of view. But then on the other side, if we see, there's also reduction in the on the developers focus, and the configuration part is mostly YAML based. So we just need to be more familiar with like how the indentation and hierarchy works. Otherwise, and there is a if there is a incorrect indentation, it can mismatch some in some rare cases in the policies also. Uh, and yeah, it's just adding more from the conceptual point of view, from the infrastructure point of view. need to have more architecture planning, so it adds some operational overhead, but then it's still beneficial uh, if we see from the benefits it provides. So that was all from my side about service mesh. And so, yeah, thank you very much. And so these are like three takeaways. It simplify microservice communication and provide resiliency, security, observability, and provide the and there are no more emerging trends in this area, like ambient mesh, which can also improve even further the service mesh communication. So that's all from my side.
Thank you, Mr. Anuj Tyagi, for your insightful and forward-thinking talk. Your session on rethinking service mesh for performance and scale from proxies to kernels introduced fresh perspectives on optimizing modern infrastructure. We sincerely appreciate your contribution to ICCC Net 2025.